Hi. Okay, guys. So, good evening. Hope everyone is doing well. So, uh, in the course of the week, I started this teaching the language, uh, taking people through, as you can see. So, today is the second tutorial that I'm holding, and hope we can we can pick up something. So, without any further ado, let's get started with the tutorial. Need to be short. I'm going to go somewhere, but I really want to get this out. Um, Let me get the entire screen if possible. Yeah, let me share the entire screen. Okay, so here we are. Now we are going to cover the first tutorial. So like I told you last time, the installation is quite straightforward. When you want to use this language, as long as you have a Debian system, for example, for me, I'm not using a Mac, I'm not using a Linux system, so I have Windows and I have WSL. So in my WSL, I have Kali and Ubuntu, but now I prefer working from Kali. I'm going to come in the terminal, you copy the command, the first command, download the deb package, you copy it and you paste it in your terminal. As long as you have internet, you click enter. It's going to download the package, the language package. As you can see, it's very light, it's very fast. Chap chap, it's done in 4 seconds. Then after that, we got the installation. Uh, we run the installation command. You put in your password, which is only known to you. And after putting in the password, the unpackaging occurs. As you can see, it's unpackaging. Let me copy the last command, which is for key fixing the dependencies. So as you can see, there are just three commands that are useful here in installation of this language. Setting up is done. There. Now we update it, we fix the packages that are would have broken during the installations or that haven't been perfectly downloaded so that it can work very well. Now after those few commands, we can we can check the version of the language that we have. uh, Rangasi version, sorry, there is a typo. As you can see, it's we see that the LVVM version, it's an optimized build. Then the compiler version is version language has been downloaded, and as I mean the compiler has been set up, and we are ready to start the development. So let me see which folders I have here. Sorry, my system is kind of slow. Not sure why. Okay, so we have got quite a lot of packages. I mean folders. Let me make one. Let me call it YouTube. Like the YouTube. Then we change directly to YouTube, and I will clear this. Uh, when I'm joining, welcome here. Sorry. So now we can start. We did the introduction last time. Now we can write our hello world program. So that's the lesson for today. Now, you saw in the previous lesson that we had, we learned about a repository of the language. So in this one, we're going to learn how to write the program, to compile it, and to run it. And we will explain every single detail. I'm going to be following this tutorial basically. I haven't made any summarized one yet because I don't think at the moment it's necessary, because right now I need people to understand how things work internally and externally. So now let's start. Let's get started by the traditional Hello World program. So we're going to create a program called the Hello Ranga here in the YouTube folder that we've created. Let's use nano hello dot ranga is the extension, and we start our first program. It's going to be as simple as this function main with the no parameters. It returns a 64-bit unsigned integer. Um, Here we have let hello, which is a pointer. Go to hello world. You guys haven't been practicing. Hope I'm not getting it wrong. And I'm going to terminate. Then I'll declare the unsafe blocks as unsafe again. So inside here, I'll do the syscall, and within it, one, and let me count how many letters are here. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14 letters, and I cross that one. I terminate. Then when don't forget to cross this and to cross this. So let's see if I, oh, sorry. Then we have to return so that we can, it knows that, I will confirm that the program is correct and it's running, because if it doesn't return, we return, we add that return. After returning, we can save our program. Then we now compile. Let's see if it passes the compile step. Hello.lwanga. Um, Let me call it hello. Too many position arguments is specified. You can specify at least one. Okay. So, uh, sorry. Let's check if I have compiled. Oh yeah, I didn't build an object. I knew it. Sorry. So back to here. Position arguments. Now this error is the position argument they are talking about. To resolve that error, I'm going to add that dot all to make sure that you will get an object. And as you can see, it has been compiled successfully. So let's run it and see if it works. Okay. And what do we have here? So it turns zero. That means we are successful in what we were doing. So what have we done? We have missed out something. I'm sorry for the blunder. Kind of thought I'm missing out on some things here. We didn't reference the variable. So let's have a hello here as our variable. Then we close. Then we compile again. Compile successfully. Okay, as you can see, we've got our Hello World program. The first one we've wrote. So if I can cut the program, you can see it's here 1, 2, 3, 4, 5, 6, 7 lines. Yeah, 7 lines, and it has been able to get us the Hello World program. How it's time to express brain. Now understanding every line. So let me I'm going to be comparing this with this screen, as you can see, but understanding every line. The first line, which is the main function, the first line FN main, the braces, then the pointer and the U64. Now that first line, the FN main is a keyword that declares a function. The main is the name of the function, and every program must have a main function. Then the empty parenthesis means the function takes no parameters. Then we have the pointing to the return of the U64, which means that the function returns the unsigned 64-bit integer, and then you have the opening brace. Why this design? Every program starts execution at the main function. The main value becomes the programmer's exit value. So zero become the zero means success and a non-zero value means error. Operating system uses this exit code to know if the program has succeeded or the program has failed. So as you see here, uh, here we will define the function and return the 64 as inside 64-bit integer, and then here we are returning zero. And like I've said, this zero is signifying that the program has successfully run or compiled or not. If it returns anything non-zero, then that means that it has failed. And how to know the return value and to know that we have been successful? We run this command: echo $sign and a question mark. You will see a zero there to show that we've been successful in running our thinking. So as you can see in an example, we have hello, and then we again check for the return value, and that's you see the comment says that return zero for success. Then line two. Now line two, which is in our case it is let hello dot colon pointer equals to, in quotes, hello comma word quotation exclamation mark and the new line tag. Then we close the quotations and we terminate. What does that line means? Let keyword is used to define a variable. In our case, we use the hello, but here in the example from the tutorials, they use the message, but just a variable name. Then the colon separates the name from the type. PTR is the type, the type of the data that we are dealing with. In this case, it is a pointer that holds a memory address. Um, Equals me is the an assignment operator. Then hello word in quotes is the string little. The semicolons that come at the end, it means that we are ending the statement. So there could arise questions like, why are we using PTR for strings? Interestingly, in lwanga, strings are just sequence of bytes in the memory. A PTR, literally a pointer. PTR is just abbreviation for pointer, so I'm going to be using the term pointer from now onwards. A PTR holds the memory address where the string starts, similar to C but more explicit. The end tag at the end of the new at the end is the new line character, and that one is shows that the cursor should be moved to the next line. Again, that's something that's something that is going to be very common when we are working with this language. This how you see how it is used in C, and we have some more tags in the future. The design choice for it, because Ranga uses explicit pointers instead of complex string types. This keeps the language simple and build smaller binaries, because we are looking at simplicity and resource management. Then the line if free. Explaining line if free, the unsafe line. This one. Unsafe with an opening carry brace. What it means. Um, Unsafe is a keyword that marks the block potentially dangerous. It marks the block potentially dangerous. So any code that resides within that code is not something that can be toyed with. It's malicious if not handled with care. And then the opening place, that's the unsafe block. Why is it needed? Could be a question. The system calls interact directly with the operating system kernel. They can access any memory, they can perform privileged operations, they can crash programs if used incorrectly. So by requiring unsafe, Ranga makes it clear that this code is doing something that can be dangerous, and I know what I'm doing. Later, that's what we're saying when you're using it in your program. The design choice. This is safer than C, where everything is unsafe, but more explicit than Rust. Since here we don't have to use, we don't have to like we don't have borrower checkouts tools, which are very restrictive. So we are flexible. That's what we can say, but safe. And then we have line four. Line four is the syscall line. Now here it is syscall 1, comma 1, comma the variable name, comma 14. We need to understand what is this. Syscall is a built-in function to make system calls. The first one is the first argument. Syscall number. It is a syscall number which is equal to write. Then the second argument, the second one is the file descriptor, i.e. 1 equals to std out. Then the variable is always the third argument, and it is a pointer to the data to write. Then the fourth argument is the number of bytes to write. Remember, I said strings are just a stream of bytes in memory. So we have to count how many of them do we have, and that is the number. So when we break it down, this is this is calling the Linux write system call. If you are conversant with Linux, you said you know the system call write, FD, buffer, and the count. So this is what we are taking advantage of directly. FD is the one that's standing for the first one, and it is like I said, it is the file descriptor in my terminal. Then the message is the variable, for example, the hello world. Then the count, like i.e. the 14 bytes is the length of the hello world program. So just to not taking it as a framework, we can count how many letters are in the word hello world, like in the quotations of hello world. Remember, this is a single character, so we don't calculate them as separate. Please, they are not separate. Uh, so we have hello at one, two, three, four, five. So the word hello covers 5 bytes. Then we have a comma at the sixth position. We have a space at the seventh position. We have a word from 8 to 13. So as you can see, 8, 9, 10, 11, 12, 13, and then the character n, the tag is the one that is terminating, is taken at once at position 14. So the system calls gives you full control and creates smaller binaries rather than using the libc functions like printf. So we are not going to use printf, but maybe we'll have the libraries in future in case you need explicitly use them, but that won't be required. We need simplicity, we need manual control. And the last line is the closing place of the unsafe block. Then after it, we have the sixth line, which is the return zero. Now, return is the keyword to exit the function and return a value. Zero, the zero is the value to return. It can be one, it can be zero. You are the one who defines which value you want to return to signify the success of the program. And then the semicolon is n is the statement. So why is zero? By convention, zero means the program has succeeded. Nine zero values means errors. But like I said, you can use any value to return. So some point you're assuming is exiting. And then we have the closing brace. The last brace is the one that is closing the main function. So that is our first hello program in Ranga. The name is Ranga. And so we have to look at how to compile the program. I'm sorry I took you chap throughout everything. Now we've known how to write the hello program. We need to see what to do with the program after writing it. we have a hello.ranga file in our folder. How to use it? Since it is a compiled language, we need to compile. Since we already installed our compiler, we run that command you see. Ranga C is referencing the compiler. I'm sure I showed me when I was checking the version again, it's the name I used. The same name I used, I mean. So we'll say Ranga C. Then what is the file name? It is hello.ranga. After that, we'll have we put the output file name. The output file name we since we output an object, we put that mark of or and then the name. If you're conversant with C, I'm sure you are conversant with a structure like that. Those uses GCC. Now we click we run that command. After running it, you will see that compilation is successful, and you will see the name of the program. The file that has been outputted is hello. So what does this command does? The Ranga says the Ranga compiler, the hello.ranga is your source file, then the -0 -o hello is the output file name or the executable. What happens during compilation? So during the compilation, the lexical analysis breaks the code into tokens, and then it is passed. The parser builds an abstract syntax tree or AST. I'm sorry, this is level for programming. Please just follow along in case you want to understand this, because again, this language is for low level developers and pen tester and pen testers, hackers, and all that stuff. So I expect you to be conversant with stuff like that. So passing is the second action, and here we build the abstract syntax tree. Now the third thing to happen after during the compilation is type checking, and here we verify types are correct, and then we do the error generation. Here the we this step creates the LLVM intermediate representation, and then the fifth step of optimization improves the code, and the sixth step generation produces the machine code. So what you should see is the compilation successful message, and to run the program, you run this simple command of hello with the location, and when you run it, you get your hello world program printed like that. Now, to confirm that the program has been successful, in case you are not printing, you run this command. As you can see, it returns 0, and since it's the return value that we set, it simply signifies that our program has been successfully operated or run. So if you've been following along, congratulations on writing your first program in Ranga. We can now, if you want to check the file size to see how much it is, you have this command of ls space minus lh hello. Remember, hello is the file that was output, so you can check how much it weighs. It is just 8.8 kbs. So as you can see, just 8.8 kbs, and it was built today. As you can see, the date and even the time is there. It's a so comparing it to C with the Sigile ellipse. C has 16 kb versus 300, and then it go has to MB. It is kind of small and very resource intensive. So you can ask yourself, why is it small? Well, no standard library and then no runtime. It runs directly on your hardware, and then direct system calls are made, and then minimal overhead. So it is simplistic. Now, we need to check what is inside the file. To check what's inside the file, you run that command, the file hello. Now you will see that hello has L64 bits, LSB executable. It's made for it was made from compiled on a 86 64-bit processor. It is version 1 SYSV and statistically linked, and it is not stripped. This tells us that it is a native executable. That's what ELF format means. And then it's a 64-bit code. It is statically linked, no external dependencies, and it can run on any Linux system. Emphasis on that. So you can check the size of the file to make sure that you don't pass the size. Maybe if maybe you're developing a payload or shell code and you have to maybe on a hackathon you have to meet a requirement. You can always mind the size of your executable, and then you can be able to reduce if it's necessary to make sure that you have exactly what is required. So here we care about resources, and we can even check what exactly is in the file, so that when you get a file, you don't just run it. When you get that executable, you don't just run it. You could know what is inside that file to know it's safe, it's not safe. You know what I'm talking about, I think. So the common mistakes and how to fix them. The common mistake, the first one is forgetting the semicolon. That's a common in almost every programming language that exists. People forget the semicolons, so that's a common mistake. So you get that kind of error, and how to fix it is by adding the semicolon at the edge. The second mistake people usually make is wrong string length. Now, when you're counting the letters of the string that you want to print, you need to be precise. Otherwise, if you're not precise, it is going to be halfway. I can give you an example. Let's use this very program that we are working with, that we've used for Hello World. Um, Here, if I come and say, if I miscalculate and I say like maybe I count 9 characters and I save, it compiles well. Yes, it compiles. Uh, but on running, as you can see, hello war. Is it? It's interesting. Hello war. Because I calculated on 9 characters, we can confirm it by doing 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 letters are being displayed, 9 characters are being displayed. Remember, even spaces are counted as characters. Even symbols are calculated as characters. I mean punctuation is symbols. So nothing is for granted in your string. And remember, a string is a pointer. So what happens when you give a wrong string length? Only the first any length numbers that you've given are the ones that are printed, and how to resolve it to have sure that you put the correct length. Another mistake is forgetting the unsafe declaration by making a system call directly from the code, and that gives an error that this call is required for the unsafe block to operate. You cannot run it outside the unsafe block. Yes, we give you control, we give you free will to do whatever you want to do, but you have to do it legally, not illegally. So you have to operate from within the unsafe blocks. Another thing I'd like to talk about is a wrong return type. As you can see in when we were defining the main function, we said that it finds a 64-bit unsigned integers. Now, when you try to return a 32-bit, it is going to give you an error. When defining it, the main function should return a 64-bit unsigned integer. So 32-bit, 16-bit, 8-bit, all those are going to be giving you issues. Uh, then validations. We have a lot of variations of that your word program, but basing on your expertise, you can choose one that is easier for you. So you can go through the version 1 with comment, then version 2 with multiple messages. As you can see, it is there. You can do multiple printing, and then the version fill with the constants. We'll look at them in the future. I'm not going to talk about them now, but I'm just saying that you can do it in many different ways. And the reason why you could use constants maybe is that because they make code easier to you to read, and they are maintained. It is maintaining and self-documenting. So now we need to understand this is cause. Many of you could be new to low-level programming, so this could be like Chinese to you, like it is to me, or Greek. Um, what is a sys call? A system call is how your program asks your operating system to do something, like writing to a screen, reading from a file, creating a network connection, doing a memory allocation. All of those are system calls. Now, how your program asks your operating system to do that thing is what we call a system call. Why not use printf? You might be wondering why not just use printf like C. The answer is printf is part of the standard C library, the libc. That's why I always import stdio.h when we're working with C. And this adds the binary size and it adds the external dependencies and adds the complexity because printf does formatting and parsing. So for hello world, but yet for hello world, we just need to write bytes to std out, and the syscall is perfect for that purpose. So the syscall right, as you can see, there is the structure that we use when we are developing this language. The syscall number, which is one, is the right. The arguments, in arguments, we have the file descriptor, which is one, and then we have the buffer point at the data, then we have the count. So that's how it was built. You have the one, which is the syscall number or the right operation. Then you have the arguments in the second comma section, which include the file descriptor. Then the third one is the variable or the pointer to the data. Then another one is the count of the bytes we are printing, and returns the number of bytes written or minus one on an error. So so in case you want to go through and make sure that you master, like if you want to be sure that you've mastered what we've talked about on your own pace, you have some exercises here below. For example, the first one is to change the message, modify the program to print welcome to Ranga instead. Then we have a solution there in case you fail, can check yourself out. Then we have exercise to print your name, create a program that prints your name. Then again, you have a solution there in case you fail to achieve it. You can always guide yourself. Then question exercise number three, have multiple lines. You have to print multiple lines, like one line, two line, if you like. You see them here in the line. Again, if you fail, you can as well check the solution so that you can follow along and see that you succeed in doing it. Then the fourth example, we're going to modify the program to return the exit code 1 instead of 0. Again, you can use the knowledge that you've gained. In case you fail, you can always refer to the solution. So the takeaways here, we've learned how to write a complete Ranga program, to structure the main function, to declare the variables we relate to, and we have learned what unsafe blocks are and why they are needed, how to make a system call, how to compile and run programs, how to check exit codes and the common mistakes and how to fix them. So tomorrow we are going to be looking at the basic syntax of Ranga. And like I've said, if you take time to watch the video, thank you. If possible, you can leave a feedback in the comment section, or maybe give it a thumbs up. I don't know, but feedback is more needed at the moment since we are in our initial release. We need your support to make it standard so that we can output the stable release. This is a test release that you're going to be installing on your computers, and that's why it is only for Debian systems. It's not yet the stable release. We are still testing everything and see that everything is working perfectly and well tested, so that once you start using it, it's not going to break. As I can say, thank you for your time. You are going to be able to watch this. Uh, Maybe you can subscribe if you want to get more tutorials about it. So if you want to get to engage with us directly, this was Cosma. Uh, Thank you for being part of this, and I think see you tomorrow for basic syntax tutorial. Bye bye.